So what is nanochemistry? It is related to very small particulate, any matter. It is broken into very small particle, or this particle size is very important. Okay, this most of the elements in the periodic table that we know, they are property that we already know, like gold. What is the color of gold? Golden. But if we go nanoparticle, gold nanoparticle, the color can be red, blue, depending on the size. So that is only one property I am talking about. That is the color. There can be many properties different. Okay. So what is the application? If I take very small particle, and in that you have a very large surface area. If it is very small particle, then there is a very large surface area. So this data we are applying. We are taking the advantage of this very large surface area. How much is a large surface area? Suppose there is a small matchbox. Matchbox, you know how much small it is. So the surface area small. But if I convert that matchbox size material into nano size, the area, surface area will become like our playground. Got the idea? You have a small matchbox. Surface area is very small. Now if you break into nano size particle, hey Ranjit, suno, golpo bando karo. So if I take this much of small box, the area is small. Now if you break into nano size particle, it will be just matchbox size material will become, the surface area will become like our playground. Our playground is quite large, so that much of area will become. So what is the advantage? If there is a large surface area, what is the benefit? Catalytic property. One example is catalytic property. Large surface area means large catalytic, very good catalytic property. Quite expected. Large surface area is required for catalytic property. So that is one property I told. What are the applications? And in the beginning I will tell you, it will create interest. That's why I am telling the application in the beginning. After that I will go ahead, how to make them and all. This one explanation. If you apply in the crop field, if you apply in the crop field fertilizer or pesticide, every year we are spending lot of fertilizer and pesticide in the crop field, huge quantity, and most of them are just washed away because in the rainy season it is getting washed and going into the some reservoir, water reservoir. It may be in the river, it going into the pond. Somewhere it is getting wasted, and that way lot of fertilizer, if it is going into the pond, that is damaging the pond also. It is leading to eutrophication. Already I have discussed eutrophication. So it will give eutrophication very fast. Okay, undesirable. But what to do? We have so many people to feed. Okay, so many people to feed. We need food. So for more food, you need more fertilizer and more pesticide. You cannot avoid that. Without fertilizer and pesticide, you cannot get sufficient food. People will be starving. So you will have to apply. So then what's the way out? If you apply too much of fertilizer, your soil will be damaged. If you don't use it, you don't get sufficient food. Okay. So that means we are in some sort of complication. We cannot avoid, isn't it? Some way or the other, either you have to use the sufficient fertilizer and pesticide also, because pesticides, if you don't use, pest will damage all the crops.
Quality of the crops
damaged totally. You don't get sufficient quantity. Everything will be damaged because crops will be eaten by the pests, and it will be halfway damaged, halfway eaten. So how do you use it afterwards? So locust, you know locust? ওটাকে বলে বাংলায় কি একটা বলে একটা পোকা আর কি. So that takes crops very fast. If it comes to the crop field, within 1 or 2 hours the crop field will be totally wiped out. The whole crop field will be eaten. So না না ওটা কি কি পোকা বললে? না না উড়ে আসে, ভেরি ফাইন, পঙ্গপাল, ওইটাই locust. Pongopal, locust. English locust, Bengali pongopal. So that always comes in a huge that number, very very large number. They are coming in millions maybe. So whenever they are coming to a crop field, they are eating the whole crop field together within a few hours, and then it's gone. So that way, if you don't give sufficient pesticide also, you cannot produce fruit. You cannot produce. That is one. If you cannot give sufficient fertilizer also, you cannot produce sufficient food. That means we are bound. You have to use fertilizer as well as pesticide. People are telling, na, too much of pesticide, don't eat that. But what to do? Without pesticide, you cannot produce food. So pesticide is a must. You can avoid, you can go for organic, but that is not sufficient. By neem tel, people are using. But is it sufficient? No, not always. Because huge crop field, how much that organic material you will get, that organic herbal is never sufficient supply. Supply is never sufficient. You need a huge quantity. That's why we are all taking the help of chemicals. Always don't blame chemical, because there is no alternative. That's why people are using chemicals. If there is alternative, people will go for organic. But whenever organic, the price is double, triple, you know. Why? Because sufficient supply is not there. Production is not there. Organic, this material, this fertilizer, pesticide, etc., not sufficient, not enough. That's why people are using chemicals. Unavailability, mainly the unavailability, and cheaper. Chemical is cheaper, and this organic is much costly, much more costly. It is 3 times, 4 times costly.
And it's easy to use also.
Chemical is easy to use. Cheaper, availability, easy to apply, all these things are always beneficial. That's what people are doing. Okay. Now both things will go. This organic and chemical, both will be there. Now coming to the point that nanochemistry, why do we apply it in this particularly agriculture field? See, as I told you already, that in the rainy season, this fertilizer, pesticide, all are getting washed away, and then that's why again and again you have to use. Apply and reapply, isn't it? Because it is getting washed away. Can't help it. Whenever there is a heavy rainfall, everything washed away, clean. Again you have to apply fertilizer, pesticide. There is a very good remedy in nanochemistry. There is a nanomaterial matrix, polymeric nanomaterial matrix, very fine nano size threads. One end of this polymer, the pesticide or fertilizer is bound, and other end is bound to the soil. If you can do that, and people are doing, one end is bound to the soil and the other end is bound to the fertilizer. So it is bound. Suppose this blue portion is fertilizer, and this portion is already fitted to the tightly bound to the ground, soil molecules or particles. Okay, then whatever rainfall occurs, maximum will be retained. They will not be washed away. 90% will be retained, maybe only 10% will be washed away. So that's a great benefit. You have to use much less quantity of fertilizer, much less quantity of pesticide. It is not that the pesticide always will have to spray only on the plant. It is required on the soil also, because soil contains lot of different type of bacteria, virus, pathogenic materials. Okay, in the soil also a lot of things are there which is damaging the plants. So that's why pesticide is required in the soil also. So let it bind. Both fertilizer, pesticide, all are bound to the soil. And if it is so, it will not be washed away. There is one good application I told you. There are hundreds. Okay, let me finish the application first, because you will be more interested then. Otherwise, why to learn this thing? Everyone think, okay, why to do? Why a small particle? So what to do with that? Let's understand where we are using. So one application I told you, another application very important. It is called nanobots. It is in the research field, in the science fiction movies you can see it. It is called nanobot. Someone is injured. Okay, so with his DNA, his or her DNA sample, the skin and cell, everything will be re-prepared, regenerated with the help of nanobots. Nanobot means nanorobot. very small microscopic robot. They are making this cell and damaged cells and damaged skin. They are repairing within 2 hours, everything clean and repaired. So no need to go to the hospital and get admitted for 2 months. The whole damage repaired within a few hours. Totally collecting this DNA sample, and with the DNA sample we will make exactly the same replica of the cell and make it. That is still a lot of progress required, but that line the work is going on. In future you will find it very, initially maybe it will be very costly, but afterwards it will be affordable to common people also. Nanobot that technology in medicine. Okay, someone has got some cancer cells. So how do you normally treat the cancers? The cancerous cell we treat, na? How do you treat normally? Chemotherapy. What is chemotherapy? Giving some poison which will kill the cancerous cells. But how we will divide this cancerous cell and healthy good cell? So when you give some poison, it will kill both. Random way it will kill the both. Cancerous cell also it will kill, and good healthy cell also it will kill. It will damage the kidney, it will damage the liver, everything. All internal organs will get damaged, and very soon there will be totally multi-organ failure. That is a very good scientific term, multi-organ failure. The person is dead. Why he is dead? Multi-organ failure. So very simple explanation then. Why multi-organ failure? Nobody asks. There is a chain reaction. Okay, mostly because of toxin. If too much of toxin gets accumulated in the body, it is inevitable. Multi-organ failure will be there, because kidney, liver, all will be affected very seriously, and multi-organ failure will happen. And too much of toxin, heart, brain, liver, nobody can handle. So toxin removal, time to time, is essential. Okay, there are a lot of methods how to remove the toxin from the body. One method I can tell you, that is turmeric. Okay, raw turmeric, turmeric paste, turmeric juice, any way you have to drink. Take small sip. This much of turmeric, at least thrice a week, is very good, essential. It is removing the toxin from the body. Okay. So, what is the nano size? 10 to the minus 9 meter. Okay. So, what is the speciality of nano? Why you are not talking about 10 to the minus 8? Why are you talking about 10 to the minus 9? Why not 10 to the minus 10? Right? What is the speciality of 10 to the minus 9? Obviously, it should come to your mind, curiosity. That is because this nano size is in between, it's a threshold between classical and quantum size. Below this size, it will become it will go in the quantum domain. And if it is larger than that, it will come into classical domain. So classical and quantum, it is just in between. It is in the threshold. Classical mechanics means where Newtonian laws are all applicable. First law, Newton's law. Newton's second law, Newton's third law. Law of motion. That you know. First law of motion, Newton's law. First law, second law, third law, Newton's law, force. So these laws are all applicable into classical domain, not in quantum. Now in the quantum domain also there is quantum mechanics, there is a separate subject called quantum mechanics. And what is the basic difference? In case of classical mechanics, a particular particle will have a specific your coordinate, specific position. Okay. Suppose you are coming into the room and you will find all the spaces empty, you can sit one place. You cannot sit in all the places. But according to quantum mechanics, the particle can be anywhere in that whole region. Obviously, you know that orbital, what is the definition? The probability of finding electron around the nucleus into space, into a certain region, isn't it? And where the probability is maximum, called orbital. So already the concept of probability you have talked about. You have seen already the definition of probability, this orbital. The probability of finding electron around the nucleus. We are talking about the probability. That is quantum mechanics. Subatomic particles are all falling into quantum mechanics. Quantum mechanical domain. If you have not seen, see Ant-Man movie. Have you seen Ant-Man?
Yes, sir.
You are supposed to see. This type of movies will give much more ideas. Lot of ideas it can be furnished, not because of only the story. You get lot of ideas from that. That is possible. It can be, maybe in future it will be feasible, like that. So quantum domain we don't know much. We know very little. Maybe you can explore more. Subatomic particle domain. How much we know? Very little. So maybe in future we will know something more. So atom so far was unexplored. It was only a concept, but nowadays we have got the picture of atom. That means whatever was our idea is true, found to be true. ইন্দ্রনীল প্রতিদিন কেন লেট হচ্ছে? আচ্ছা এদিকে দেখো। আচ্ছা, so normally you have to supposed to know what is the nano size means. Nano size means what? Some rough idea that what is the nano size. So we talk about nano. So let's talk about what is the actual size. You will understand. Acha, see, this is nano. Giga, mega, kilo, centi. These are all units. Centi, milli. These are some factors like millimeter. So milli factor with meter. So it's a factor. So mega is a factor. Giga is a factor. Factor multiplied. So gigabyte. Okay, megabyte. So this is a factor. Kilo. Okay, how much you will take? So kilo. So it's a factor, some unit. So here nano is the factor, 10 to the minus 9. And what is the speciality I told you? It is a in between the classical and quantum domain. The size is so that it is in between classical and quantum. So that is the advantage. Achha, now if you have nano size particle, it can change color. By studying nanomaterials, maybe in future we will be able to make invisible man. Science fiction. Yes, science fiction becomes true afterwards. So these nanomaterials are like that. They have a lot of potential. We need to explore them. Now, it is not nothing new. In Egyptian technology, that very old ancient Egyptian pyramid, we have got some cup where nanomaterials coating is there. That means this Egypt also used nanomaterials so long back. And that what is the specialty? The size. This particular size. How do you make it? By breaking into from big one, breaking, O1 breaking, finer, ultimately go to nano. This is called step down. Otherwise, you can make it step up, starting from very small molecule combination of molecules forming nano size. Two ways it is possible. Top to bottom, bottom to top. Downward or upward. Starting from a big lump, breaking into small powdery, and then finer going to nano size. Otherwise, you start from molecules are agglomerating, merging together, forming a nano size. Got it? So these two ways it can be done. Big size to small size to big size. That way the nano particles are made. Okay, let's go ahead. Some pictures. See, these things if you note, you will understand. What is nano size actually mean? Red blood corpuscle size, you have more or less, you can realize how much size it is. Red blood corpuscle, we can see in the microscope. So the size you can more or less have an idea in mind. Now, 7,000 nanometer wide is our RBC. Our red blood corpuscle, which is microscopic, under microscope only you can see that, not in open eyes, naked eyes, you cannot see that. So 7,000 nanometer is one RBC. Okay. Water molecule, how much size it should be? Very small, beyond our imagination, it is 0.3 nanometer. 0.3 nanometer. So I understand now what is nanometer size. What is the advantage? These nanometer size particles will have a lot of property which is not available in normal size. Gold is magnetic or non-magnetic? Who can say? Non-magnetic. Nano gold is magnetic. Nano gold is magnetic. Achha. No, not how. Achha, one thing. First of all, tell me how magnetism appears into a metal. How magnetism comes? By dipole. But no, I'm talking about molecular level. What happens in the material that it is magnetic, and what happens to another material which is non-magnetic. And one piece of iron, you can make it magnetized and get it make it magnet. But originally it was not magnetic. So what property you have imposed there? How do you do that? By sending some electricity and all, it has become electromagnet. But that electricity is gone, but magnetism is there. How?
It's a property.
No, you have to understand in the molecular level. Should not give superficial answer. You have to understand molecular level. That what is happening. You take a piece of metal, iron, then wrap it with some coil, that wire, and pass electricity through that. After some time passing some electricity, remove the coil and take the bar, you find it has become a magnetic. At least for some time it will retain this property. What does it? What happens inside the bar? Actually, what is happening inside the bar? That you need to understand. So these molecules of iron molecules, it is having some unpaired electrons. Okay. So these unpaired electrons are all because of spin creating certain magnetic field or magnetic domain. Okay, some sort of magnetic some moment it is creating, magnetic moment. It is called magnetic moment. So it is creating some magnetic moment. Each and every spin of electron that is present in the iron atom. So many atoms, they are not aligned. They are disoriented. Random direction they is scattered way they are having. The molecules are in different direction. So magnetic moment is not aligned. That is non-magnetic. When you apply magnetic electric field, electric current, then all become aligned. Because of this force field interaction, all become aligned in one direction. Then you are getting north pole, south pole. Aligned. Okay? You all have potential. We are not doing anything. Trying to make you align in the right direction. Then you will have a lot of potential. Got it? All the students are having lot of potential. Sometimes you are making something very good that I cannot make. It happens. So then what is our role? Alignment. So here magnetic field is electric field is applied to make the molecule aligned. Nothing else. Okay. So gold, it has not at all aligned, and these are not also magnetic material. Gold is not a magnetic material. But whenever it is coming in the nano size, which is very, very small particle, then surface energy becomes too high. That is called surface energy. When particle having a large surface energy becomes very high. Okay? Residual attraction. It is sort of residual attraction. What is the meaning of residual attraction? After making bonds also, it is not satisfied. So in the surface, it is always hungry and trying to accept more number of bonds or some atom. It is trying to pull other atoms. Some sort of attraction exists on the surface. That is the surface energy. Now, the surface energy of this non-magnetic material also is becoming such that they are becoming more aligned compared to our bulk materials. Big lump. Compared to the bulk material, big lump, these very, very tiny particles, they are aligning in a better way. So some magnetic character is there. Now one thing, how do you use it? If it is becoming magnetic, so what? Now coming to that point. This gold is very, very inert. That's why it will not react into our body fluid or body cell or enzyme. It is very much inert. So you can safely insert any gold into the body. Okay? But any other metal you cannot. Gold, platinum, these things can be inserted. Titanium. Some elements are there, metals are there, which we can make titanium plate, implantation, that you can do. Gold also can be injected in the body without much chemical reaction because it is very much inert. That's all. Now, if you put some medicine and that medicine attached to that gold particles, medicine attached to the gold particle, and these gold particles are magnetic gold particles. The whole thing injected in the body. Now apply magnetic field from outside, you apply certain magnetic field and guide the particles in proper direction. It will go into the cancerous cell, near the cancerous cell, and dump all the medicine over there. Instead of giving everywhere, it is carrying the whole thing, and we are controlling from outside by applying magnetic field. And exactly at the location where cancer cells is there, you can see from outside in the computer monitor, you can see that, and there you dump it. All the medicine is spread, released from the gold. So that is one type of treatment, targeted medicine delivery. Targeted medicine delivery. You can do lot of manipulation. You can change where it will go and where it will not go. You can totally control by applying very tiny magnetic fields, because it will interact with that gold. Gold will interact with that magnetic field, and this magnetic interaction can be always in a controlled way fashion. So whole machine is obviously costly nowadays, because it is just the beginning. Now when it will become very popular, it will be cheaper. So this is what? This is our human hair. In a nanometers, in nano range, we magnified it. So nanoparticle is very, very small, but it is, suppose if I take our hair, human hair, in the nanometer scale will be 20,000 nanometer. The thickness or width of the hair is 20,000 nanometer. And our blood, RBC, 7,000 nanometer. Water molecules, 0.3 nanometer. So from this you can get some rough idea what is the nanometer size. And what is the speciality? It has got different property altogether. Why do you need? Because it has got altogether different property. Bulk material is a different property, and nanoparticle has got a different property. And we have a lot of application. Explore more and more what application can be there. That is under exploration. So, how surface area increases, just see. This is a block. You break into these some segments, cut it with knife. Suppose this is a big cake. This is a big cake. So you are cutting into this way, this way, this way. So many pieces you will get, 16 piece. কতগুলো পিস হবে দেখো তো, একবার এইভাবে কেটেছো, একবার এইভাবে, একবার এইভাবে তাহলে কতগুলো টুকরো হচ্ছে? 1 2 3 4 5 6 7 8 আটটা আছে, আট টুকরো হয়েছে। ওই যে কাটাগুলো দেখো, এটা 8 টুকরো হয়েছে। এটাকে যদি আরো কাটতে থাকো তাহলে বড় হবে, আর নাম্বার অফ পিস উইল গেট মোর অ্যান্ড মোর, সাইজ উইল বি স্মলার অ্যান্ড স্মলার। দ্যাট উইল গো অন কাটিং with machines or with instrument or something like that. So go on cutting it. So your surface area is increasing, and not only surface area, surface energy also. And surface energy gives different properties like catalytic property, magnetic property. This type catalytic property. Yes, large surface area will give a very good catalytic property. It will be a catalyst. So there can be magnetic property, and that already we use in the medicine field, as I told you. One application. There are numerous applications. Targeted drug delivery, you understood? Acha. Now another one. Controlled drug delivery. Sometimes some people, those who are taking hypertension drug every day, hypertension drug. So hypertension drug, you understand? High pressure oshud, high pressure medicine. So one medicine in the morning and one medicine in the afternoon. Suppose someone. So when you take one medicine in the morning, the effect is very high. So it goes to the peak. Effect. Concentration is high. So it is going to the blood. And then and there, the effect is very high. So you can make it a plot. It will go at the peak. And then effect will fall. Go on falling. And at around 2 or 3 p.m., the effect is very nominal. Then again you have taken another drug at 4 p.m. So again the effect, it is becoming high. So there is a lot of peaks like this every day. Morning, afternoon, you are giving, your body is exposed to that sort of thrust. One thrust in the morning, one thrust in the afternoon. So that is very bad for the kidney, for the whole system. Liver, kidney, all are getting affected. Damaged that way. Heart, liver, kidney, all internal organs getting damaged because every day taking medicine. Or without medicine, you will not survive. So you have to take the medicine. You have to take the medicine. But if you take medicine, it is damaging your internal organs. না নিলে মরে যাবে আর নিলেও আস্তে আস্তে মরছে there is the remedy that's what I'm telling you take some cage and your medicine inside the cage right so there are gaps through the gap the medicine can come out molecule by molecule only not as a whole one molecule 2 molecule it is coming out throughout the day there will be no thrust. So it will be always inside the therapeutic window. It is called therapeutic window. These ups and downs should be within a certain range. That range is called therapeutic window. It is not going beyond that. Not going below that also. Controlled drug delivery. Slow medicine is going out. Some capsule also doing. Nowadays we are making capsule like that. So capsule will not be totally dissolved. Some portion will be dissolved, so from there some leakage of medicine through the capsule, and the whole dissolving the capsule takes the whole day. Dissolving the capsule takes the whole day, and as a result you are getting the medicine throughout the day. That is the way out. Okay, but earlier days this type of treatment was not there. Taking one drug, it is giving a high peak, and then effect is gone, it is getting minimized. Again you are taking another one and it is damaging the whole body. But nowadays this type of treatment has come. And where nanomaterial is there, nanomaterial what will do? Nanomaterial, this medicine is bound to the nanomaterials. It is always not gold. It may be polymeric nanomaterials, which is biopolymers. And the best is biopolymer will not give effect to our body because we are also biopolymer. So it will not affect our body. So by some biopolymer, some sort of protein in it is bound. Okay. So this biopolymer is nano size material. Okay. Surface area is very large and effect is also very high. If the surface area is very high, effect also is very high. Because every surface some sort of active surface is present. So you can use every active surface position. So that with a little bit of this nanomaterial, you can do the job. You don't have to consume a lot. You have to consume a very small quantity, and that is always desirable. Take only small. So effect will be high because your side effect will be very minimum. If you take small quantity, your effect is good, but the side effect minimized. So what is this actually? It is showing that if you go on breaking into a small block into nano size particle, then the surface area will become like a very big playing ground, as I told already. So see different 17.5 all these things are written. So what is that? 1.5, 2.9, what are these? This is the nanometer size gold particle giving different color. Gold nanoparticle, different size is giving different color. 1.5 nanometer giving violet color. 2.9 blue color. Okay, 4.6 maroon color going towards red. And 17.5 is much larger size. It is giving you pink color. So different color is there.
So how the color is changing?
Acha. Nano size particle, when it is coming in front of a light passing through it, the light getting bent because the size of the particle and the size of the wavelength is matching. That's why it has a capacity to distract the light. Light is getting distracted. It is going bending in a different angle. Normally light goes in a linear way, but if there is some barricade in the front, it gets reflected, isn't it? But the barricade size, if it is in the same size of the light, then it will become bent. So light is bending. Different size is bending light in different angle, and we are getting different color because we have a only sensation that which light is coming to our eye, we can see that. So light is bending. So a particular frequency light is coming to our eye and others is not coming to our eye. So we get the color. Light is bending. That's why I told no. That invisible man will be possible in future. You bend light in such a way it will not come to our eye. So you cannot see the person. Bend the light in such a way that it will not come back to our eye. You cannot see that. Okay? You will find some blank position, blank space. That means light is passing through. And that means it will be invisible, no? So that invisibility is possible with this nanotechnology in future. That's the dream of the scientist, making invisible man. Gayab, there is a movie. দেখনি দেখনি কেউ গায়েব মিস্টার ইন্ডিয়া দেখনি তো এগুলো কি বলছে সায়েন্স ফিকশন ইন ফিউচার মেবি ইট উইল বি দেয়ার ইট উইল বি পসিবল ফিজিবল ইটস নট ইম্পসিবল আচ্ছা নাও কামিং টু ডাইমেনশন অফ ন্যানোপার্টিকেল ন্যানো ক্যান বি dimensionless. It is called nano dot, okay, or quantum dot. Nano dot or quantum dot. It is dimensionless. Means all different angle, different orientation. If you measure the length, width, height, everything is in the nano size. It is called nano dot or quantum dot. It is called 0D, zero dimension, because dot is always dimensionless. You put a dot into the board. If I tell you what is that dimension, you will say no dimension, non-dimensional, is it? For dot, a dot is non-dimensional because you cannot measure the width, height, nothing. So nanoparticle is also like that. If it is in the nano size, all different direction, then it's a nano dot, dimensionless. So it is 1D. Now, if you have a thread. So thread, only the width of the thread is in the nanoscale, but the length is not. Then is 1D. 1D. Yes, 1D. You have got a film, very thin film, which is nano thin film. And you get the idea, if nano thin film can be prepared that way for our different layers of our battery, then how much will be the capacity of the battery? The films are made in surface area will be very, very large, huge. You think about your storage system, your hard disk. This much of hard disk will store so many petabyte data. This much of small hard disk, like a matchbox, can contain petabyte data, not gigabyte. Petabyte, you know? 1000 gig is called petabyte. 1024. Oh no. That everyone knows. That is skipped. Terabyte. Terabyte is already there in the market. So we have 1 TB hard disk, 2 TB hard disk. Next is petabyte. Next coming is petabyte. So what I am telling, this much of matchbox can hold petabyte data. Just imagine. Why? The surface area is enormous. So it is 2D. Thin film. Thin film. Okay. Thickness nanometer scale. Thickness nanometer scale. But the area is not. Then it is 2D. And what is 3D? Nano 3D? These small dots combined together forming in 3 dimension, but each and every one in the nanometer range. It is nano 3D. So it is a composite. It is called nano composite. Looking big, but here the whole thing composed of millions of nanoparticles. That is 3D. Looking 3D is like this. Nano 1D, 2D, 3D, etc. Now composite. Different type of nanoparticles can be combined together. So give variety of applications and variety of properties. It will help a lot in future. Chemistry, science, space science, everywhere. Lot of applicability. See, what is this? Carbon nanotube. It is called CNT. How do you make it? Don't have to make. It is already there. In nature, you take a lamp black, analyze, you will find some fullerene, some nanotube, everything there. Just you have to separate them. Some carbon particle, which is carbon does not mean always C. It can be C60. C60 means carbon fullerene, Buckminster fullerene. There can be C72, tube type, tube. So nanotube. So these nanotubes made by carbon is called CNT, carbon nanotube. Application: this tube like this allow the water to pass through the tube. This water contains, and the tube is made in such a way, this side is thicker and it is becoming thinner, narrower. This is wider, this side is narrower. Possible? Okay. And this at the end, it is very small gap. So water along with the heavy metals are entering into the tube, and when the water is going out, the things are blocked. Means the undesirable things are all blocked inside the nanotube. After that, you discard all the nanotubes along with the heavy metals. Application of nanotube.
Acting like filters.
Yes, filter, but it's a micro filter or nano filter rather, not micro, nano filter. So see the beautiful thing. Anything you undesirable you can remove by applying millions of nanotubes, and nanotube will take care of everything. They will collect all these things, unnecessary things. By adsorption also. Why not? Because they are having very high surface area. So adsorption and surface energy is very high, very large. So they have attracting capability. It will attract everything. And water will be simply free of all the impurities. Purification. So these pictures in front of you, this is already I have discussed that fertilizer and pesticide blocking. So this is the fertilizer pesticide blocking type of nanomaterials. Nanomaterials bound to soil, one end, other end is bound to fertilizer or pesticide. So it will not allow to wash away. So 90% will be retained, only maybe 10% will be washed away. So every time you will have to apply very small quantity of fertilizer and pesticide, 1/10 time, 1/10%. Instead of tons, you have to apply kgs. Got it? So that's it. This is what? Missile. Missile, you understand? Missile? It a missile. So nanoparticle can be made by different type of nano materials are discussed here. 1 dimension, 2 dimension, metal based materials. These nanoparticles can be made of metal, can be made of non-metal. Okay, depending on the requirement. You can make it out of polymer also, polymer nanomaterials. So then it is non-metal. Metallic nanomaterials like gold. Gold is very common, very famous because it is applied in medicine. Any other metal we cannot use because gold is the only thing that will not react into our body's tissue. So it will not give reaction. So you can think that gold is very costly, so the whole treatment will be very costly. No, because nano is very small quantity. So that's why the treatment cost will be not that high. Quantity is very small, unimaginably small. One ring can treat so many people. One ring, gold ring, can treat so many people. So the price will be divided and the cost will be very small. Now coming to the preparation. How do you prepare? Breaking into small, fragmenting into smaller pieces. Okay, this is the way we are hammering, breaking. So breaking, okay. This person is breaking the stone. So hammering and breaking, and finally going to nano size. Another one, mechano set. Some children are playing with this small things. They are joining together to make some truck, some small heart. So different type of things just joined together. It is called mechano set. So this is the mechano set. So that way also you can do. So different type of methods are there for making nanomaterials. So first of all, gaseous phase methods. So you take some gaseous phase carbon dioxide. It discharge electricity. So carbon dioxide will decompose, producing carbon black. So carbon decomposition, vapor state to directly carbon decomposition into carbon particles. That will contain nano. So many methods I will tell you. One practical method we are using in the lab. Nanomaterial preparing. So how? First you take zinc nitrate. Hey, please stop talking. Don't talk. Zinc nitrate solution. It is a highly soluble. Zinc nitrate solution you make. Saturated solution it should be. Okay? And into that you have to apply ammonium hydroxide dropwise. Zinc hydroxide will be produced in the nano size. Okay, so when the zinc precipitation is going on, then you have to dip some plate, maybe glass plate, take it out, dry it into oven. Afterwards you will find a thin film is coated on the surface. That is all nano size particle. Okay, so making nanomaterials is not impossible. It can be done into ordinary environment. Only different type of ideas you have to understand. Then liquid phase method, gel type, you have a gel, sol gel technology, colloid. So there precipitation of salt into gel going on. Sulfur colloid. How do you make it? You have sulfurous acid. How do you make sulfurous acid? SO2 dissolve into water. Sulfurous acid. Okay. Pass H2S into that. SO2 dissolve into water, that is sulfurous acid. There you pass H2S gas. Sulfur deposition will take place, but this sulfur will be in the colloidal size. Okay, I think time is up.